Hi friends, welcome to Cracku's video series. In this particular video, we'll be taking a look at the formula for installments. Now, basically a lot of people have difficulty understanding what is installments and why does installments affect how much is paid back. So let us take a look at what interest is and how essentially there are two ways of paying back a loan as such. So interest is basically when you take 10,000 rupees and say the interest or rate of interest is 10%. Firstly, your 10,000 rupees is going to attract this 10% every year. So after 1 year, the total outstanding amount would be 10,000 plus 10%. So it is going to be 11,000. Now, for the next year, this 1,000 that was added, which was basically the interest of last year, is also going to attract interest. So basically, whenever you take any loan, the total amount outstanding is essentially going to attract interest. Now, there are two ways in which you can repay back a loan. You can repay back a loan in lump sum. So I will take a loan at the start of the year and I will repay it back after 2 years, at the end of 2 years. There is nothing that I will pay back in the middle. Most of the banks or most of the lenders do not want that kind of a system, because when the lump sum payment comes, most people default because they have not really prepared or put money away for that kind of a lump sum payment. So instead of a lump sum payment, most lenders these days prefer a EMI type of a payment. So what is EMI? EMI basically means that every month or at the end of every quarter or at the end of every year, you give back some of the loan amount as such. This EMI is part principal repayment and part loan interest repayment. Now when you have EMI transactions, what is basically happening is that because you are not paying at the end of the entire duration, the total loan outstanding amount is not necessarily increasing throughout the year. So earlier when you had this kind of a structure, you had total at the start of the loan, you would have 10k outstanding. At the end of 1 year, you would have 11k outstanding. At the end of 2 years, you had 12.1k outstanding. At the end of 3 years, you had 13.31k outstanding. The loan amount would continue to increase as such, because there you had to pay a lump sum of 13,310 at the end of 3 years as such. But this is not the case with EMI. With EMI, at the end of the first year, you have interest which is increasing, and secondly you have EMI which is getting reduced. So the total loan outstanding is not increasing but actually decreasing with time, because you are partially repaying the loan every year as such. So in EMI repayment, how exactly, in when you have installments as such, how do you calculate how much installment has to be given? So there is a formula for that. The concept that is behind it is basically of present value and future value. Present value basically means that when you take a loan today, okay, so the present value of the loan that you take today on day 0 is, suppose you take a loan of 10,000, the present value of this loan is 10,000. This is the money that is added in your bank account. Now when you pay back your EMI, suppose the EMI amount for it is for say 3 years, you pay back say X every year at the end of every year for 3 years. So this is this is at year 1, this is at year 2, and this is at year 3, and this is basically start of the this as such. So this is at t equal to 0. So at the start of the first year, you get 10,000 in your bank account. At the end of 1 year, you give X, end of 2 years, you give back X, and in the end of 3 years, you give back X. So these are equal installments as such. EMI is basically equal monthly installments, but you can have equal yearly installments also. So essentially, all of them will be equal as such. And the idea is that the value or the present value of these three installments will be equal to the present value of the loan. So 10,000 will be equal to X, the present value of this, the present value of this, plus the present value of this. Now what is the present value of this? See, if I wanted to give X at the end of 1 year, okay, if I want to give X today versus X at end of 1 year, which would be actually better and which would be worse? See, if I got X rupees today, I'd put it in the bank for the rate of interest that this loan guy is charging. I'll get that rate of interest and I'll pay you back X at the end of the year as such. So X today is always better than X 1 year down the line. And how much better is it? It is basically better by the rate of interest. So X today is basically the amount or equivalent amount would be this amount, that is present value, will be equal to the future value of X into 1 plus R by 100 as such. That is the 1 plus rate of interest by 100 for 1 year. So this would be the future value after 1 year. So if I say that I'm going to give you X at the end of 1 year, its present value will be basically x divided by 1 plus r by 100. I am discounting the value as such because this is 1 year in the future, so I have to discount the value today. Another way of thinking basically would be that you know that you have to give x value at the end of 1 year. How much money do you need to actually deposit in your account today? If you had to deposit the same or equivalent amount in your account today, you would have to deposit x divided by 1 plus r by 100, because over the course of 1 year it is going to earn interest at the rate of 1 plus r by 100. So it will be x divided by 1 plus r by 100 into 1 plus r by 100. This would be the total amount at the end of 1 year. This will cancel with this and you will be ending up with x. So the present value of this x is essentially x divided by 1 plus r by 100. What is the present value of this x? This is for 2 years. So this will be x divided by 1 plus r by 100 the whole square, because I am dividing for 2 years. So if I have to find out what is the equivalent value that I have to put in a bank account today so that it is worth x 2 years down the line, I would have to put in this value. Similarly, this is equal to x divided by 1 plus r by 100 the whole cube. In general, the formula for this, if I am equating by present value, is that if suppose I have borrowed value of principal amount of p and I am going to pay back in equal installments of x, then p should be equal to x divided by 1 plus r by 100, where r is the rate of interest at which the interest is accruing, plus x divided by 1 plus r by 100 the whole square, and so on till x divided by 1 plus r by 100 raised to n, where n is the number of terms for which this particular loan is taken. So suppose if I take 10,000 for 3 years at 10% rate of interest, then 10,000 will be equal to x divided by 1 plus 10 by 100 plus x divided by 1 plus 10 by 100 the whole square plus x divided by 1 plus 10 by 100 the whole cube. So essentially I am equating all the present value of all of these things. In general, you can either do this, but I don't like things to be in the denominator. It is kind of inconvenient to write as such. So another way you can essentially do is multiply the whole equation by 1 plus r by 100 raised to n. So if I multiply the whole equation, this equation, the LHS as well as the RHS by 1 plus r by 100 raised to n, then essentially I get the second equation, which is p is into 1 plus r by 100 raised to n is equal to x into, so I take x in common. So basically this is raised to n divided by 1 plus r by 100 by raised to 1. So this would be 1 plus r by 100 raised to n minus 1, then 1 plus r by 100 raised to n minus 2, and so on till finally you have where it is multiplying with this, you will just have plus 1. So essentially in this case, what am I comparing? In this case, instead of comparing present value, so instead of saying that okay, this is p today, this is x, this is x, this is x, what is the present value of x now, what is the present value of x now, what is the present value of x now, what I am instead doing is that I am comparing future value. So if I put p in a bank account today at r rate of interest, what would be the future value 3 years from now? The future value of p if at r percent rate of interest would be 1 plus r by 100 raised to n after n years. What if I put this x value for n minus 1 years, what would be the future value of this x after n minus 1 years? That would be x into 1 plus r by 100 raised to n minus 1, and so on. What would be the future value of this x if I put it in a bank account for n minus 2 years? That would be x into 1 plus r by 100 raised to n minus 2. So both of these formulas are essentially equivalent. You basically multiply the formula with a constant on LHS and RHS, you get this. I generally prefer this formula. The reason why I prefer this formula is because there is nothing in the denominator, no pesky numbers in the denominator, which makes calculation easier and more intuitive to remember. So this is basically the formula for installments. We can understand this better only if we start solving questions. So consider the first question. So consider this question. Bablu borrowed 20,000 at a compound interest of 20% for a period of 3 years. Instead of repaying the loan at the end of 3 years, Bablu plans to repay it in the form of 3 equal installments at the end of each year. How much money does he save approximately in this process when compared to paying the complete loan at the end of 3 years? So we have what is the amount that is coming in at the start? This is 20,000. And he is going to repay back at the, in 3 equal installments. So let the equal installments be of X. So this is at end of first year, this is at end of second year, this is at end of third year. So what is the future value at the end of 3 years of this 20,000? How much would be the total accrued value at the end of 3 years if it is at 20% rate of interest? That would be 20,000 into 1 plus 20 by 100, the whole raised to cube. So this would be the future value of this principal at the end of 3 years. What would be the future value of this at the end of 3 years? Because this is 1 year in the future, it is going to accrue for only 2 years. So this value will be X into 1 plus 20 by 100, the whole square. This is going to accrue for 1 year. So this will be X into 1 plus 20 by 100 raised to 1. And this last installment you are actually paying at the end of 3 years. So it is basically at the time only it is worth X. So this will be equal to X only. So this is the installments equation that we have. So from this equation, if we solve, we will get the value of X. So let us try to simplify. 1 plus 20 by 100 is basically 1.2. 1.2 cube is 20,000 into 1.728. This is equal to, I'll take X in common, this is equal to 1.20 by 100 is 1.2, 1.2 the whole square will be 1.44, this is 1.2 and this is equal to 1. So this is equal to how much? This will be equal to 3.64. So this is 3.64 times X. So how much is X equal to? So X can be written as X is equal to 20,000 into 1.728 divided by 3.64. So this would be roughly equal to 34560 divided by 3.64. If I calculate 364 over here, 34560, this is 9 times 364 into 9 would be equal to, this is 36, 54, 57, 5, 27. So that would be equal to 32. So this would be 3276 lesser. So this is 0, this is 3, this is 8, this is 180. So this is 1800. 364 into 4 will be equal to 16, 25, 2, and you have 12, 14. So this will be equal to, into 4 would be equal to, this would be 1456. So this will be equal to 344. 344, again I will say 9. So this will be 0 minus 3276. I will be left with 3, this is 4, this is 3. So this is 6, 1640, 1640, again this will be 9494. So the each monthly installment or value of X is roughly equal to 9494. Basically, I get 34560 divided by 3.64, which is slightly less than 10,000. So the value of X that I am getting is essentially 9494. In all of these cases, I would highly recommend using the calculator, because you would not only save time doing this, but also basically you would the amount of accuracy that is required in this case is fairly high. So I would suggest that in all such cases when installments is considered, you should use the calculator, especially at the last moment when you have calculated or done all the interim steps and one division is left. Definitely use the calculator. So now I found the value of X as 9494. Now what is essentially asked? How much money does he save approximately in this process when compared to paying the complete loan amount at the end of 3 years? See, if he paid the complete loan amount at the end of 3 years, that would have been 20,000 into 1.2 raised to the whole cube, because that is essentially the principal into 1 plus r by 100 cube. So this we found to be equal to 34560. Okay. Now instead of that, he is paying 3 times 9494. 3x of or 3 times 9494 will be equal to how much? This is 12, 27, 28, 2, 14, 28 as such. So this is about, he is paying 28,482 instead of 34560. So the difference is 34560 minus 28482. So let me clear this up. So the difference is 34560 minus 28482. Roughly this should be equal to, this is 5, this is 8, this is 4, this is 78, 0, This is equal to 6078 roughly. The value that I am finding which is close to that is basically 6076. So the correct answer should be option E. In this case, basically use the calculator as much as possible because accuracy is important over here, and this is going to be calculation intensive, but don't jump at the calculator immediately. Simplify the particular equation as much as possible and then use a calculator. So as you saw in this particular case, once you found the equation for x, it is easy to solve. So the equation for x you get from the use of the formula, and in this case the answer is option E. Let's consider one more question on this. So Raju borrowed a sum of 12,000 at 10% compound interest per annum from Ravi. If Raju repaid the amount in 3 equal installments, with each installment to be paid at the end of the year, find the value of each installment. So he took 12,000, okay, and he paid it back in 3 equal installments, say of x each. So this is at the end of first year, this is at the end of second year, and this is at the end of third year, okay. So what is the future value at the end of 3 years of this 12,000? That will be 12,000 into 1 plus 10 by 100, the whole cube. This is equal to the future value of this after 2 years. So this is x into 1 plus 10 by 100, the whole square, plus this future value of this at the end of 1 year. So that is x into 1 plus 10 by 100 raised to 1. And the future value of this, because it is given at the same time, future value of x at that point of time will be x only. So this is what this is going to be equal to. This is the formula that we have, and this is how the equation that we get. So 12,000, this is essentially 1.1 cube. So 12,000, 1.1 cube is 1.331. This is equal to x into 1 plus 1.1 square is basically 1.21. This is x into 1.1 and this is equal to x. So this is equal to x into, if I add this up together, I get this is equal to 3.31 as such. So x is equal to 3.31 times x is equal to 12,000 into 1.331. So what is the value of x? So if I just put this calculation, 1.331 divided by 3.31, use a calculator. If you use the calculator, you will find that the value of x is roughly equal to how much? It is equal to 4825. In all these scenarios, because if you see the values also, I would recommend against trying to guess at the value or trying to find the value through approximation, because here you have 4825, here you have 4736, here you have 4900. All of these values are fairly close to each other. So with close values like this, use a calculator. It is important to actually not guess in such situations. You should use the calculator in such situations. So the value of each installment is 4825. Let's consider the next question. So consider the following question. An amount of 3,64,000 which compounds annually at the rate of 20% per annum is repaid in 3 equal annual installments. Find the value of each installment. So again you will find the value of installment. Here you are given 3,64,000 at the start of the first at t equal to 0. After year 1 you pay back x, which is the equal installment. At the end of year 2 you pay back x, which is the installment. At the end of year 3 again you pay back x, which is the installment. Now what is the future value of this 3,64,000 at the end of 3 years? That would be 3,64,000 into, this is 20% per annum, so 1 divided by 20 by 100 cube. This is equal to the future value of this, so this is x into 1 plus 20 by 100, the whole square, plus x into 1 plus 20 by 100 raised to 1, which is the future value of this. This is compounding for 2 years, this is compounding for 1 year, so this is raised to 2, this is raised to 1, and this is compounding for 0 years, so this value is equal to x only. So this is equal to how much? This is 364,000, 0 into, this is 1.2 the whole cube, so that is 1.728. This is equal to x into 1.44 plus 1.2 plus 1. So this is equal to 3.64. X is equal to this 3.64, 3.64 lakhs, 3.64 x. So you can say that x is equal to 364,000 into 1728 divided by how much? This is equal to 1.728 divided by 3.64. So this times 1, this times this is 3.64, 1, 2, 3, 4, 5. This is 10 raised to 5. And this is essentially 3.64 times 1. This is 3.64 times 10 raised to 5. So this is 10 raised to 5 into 1.728. So this will be equal to, I will put the 1.72800. So this is 172800. So the value of x is going to be equal to how much? This is 1,72,800. So the value of each installment is option C, 1,72,800. In this case, you don't really need a calculator because 3.64 is getting cancelled off from both sides. But if it doesn't get cancelled out, use a calculator. Now consider the next question on this particular topic. So let's start. Raju bought a laptop for 50,000 and paid 8,000 as a down payment. The remaining amount was to be paid in 3 equal installments, annual installments at the rate of 20% per annum compounded annually. Find the value of the annual installment. How much is the remaining amount? See, he has paid 8,000 directly. So 50,000 is not the total amount that is taken as loan. 50,000 minus 8,000, that is 42,000 is the amount which is taken on loan. So this is at t equal to 0. At the end of 1 year, he's going to pay back x. At the end of 2 years, he's going to pay back x. At the end of 3 years, he's going to pay back x. The value of this 42,000 after 3 years would be how much? This 42,000, if the rate of interest is 20% per annum, this would be 1.2 the whole cube, because it is 1 plus 20% cube. So that is 1.2 the whole cube. This is going to be equal to x into, this is going to compound for 2 years. So this is going to be 1.2 the whole square. This is going to compound for 1 year. So this would be x into 1.2 and finally equal to x. So this is equal to how much? We found it earlier. This is 3.64. So this is 3.64x and this is 42,000 into 1.728. So what is the value of x? X is equal to 42,000 into 1.728 divided by 3.64. So if I calculate using a calculator, I get the value of x to be equal to 19940. I would suggest do not actually use a, do not try to approximate it, because this is 19940, this is 19924. They are so close to each other. So it would not be right for us to approximate in this case, and therefore the correct answer to choose is option C. So this is basically how you should use the formula for solving questions on installments. Remember, draw out the diagram, because the diagram will clarify the formula. This is the present value. Find out, equate all the future values as such. So future value of this 42,000 has to be equal to the future value of this installment and this installment and this installment. So the future value of all installments together should be equal to the future value of the loan taken. Using that formula, you can find out the value of each annual installment. So this is basically how we solve these questions based on installments.